Hi, Math 2E. The first problem is asking us if x minus 3 is a factor of the given polynomial. In order to be a factor, I would have to get a remainder of 0 when I do my division. I could use long division here and use the x minus 3, but I'm going to use synthetic division, so I don't want to use the x minus 3. I want to use the root of x equals 3. So I'm going to use my 3. My coefficients are 1, 3, -1, -3. I'm going to bring down my 1. I'm going to multiply by 3. I'm going to add and get 6. I'm going to multiply by 3. And I can see that I am not going to be able to get a remainder of 0. So this means that no, x minus 3 is not a factor of my polynomial. So in the next three problems, we have to factor. So 2 and 3 are both the sum and the difference of two cubes. So the sum of two cubes and the difference of two cubes are a pattern. It's going to always factor into a binomial times a trinomial. And I just need to figure out what my parts are. So for number 2, when I do the cubed root of x cubed, I get x. And the cubed root of 216 is 6. So when I put my numbers into my parentheses, the first parentheses are my cubed roots. It's what I see. I see the x and 6. I'm going to write it. The second parenthesis is the square, the product, and the square. So x squared is x squared. The product of these two is 6 times x, or 6x, and the square of 6 is 36. And then I get my signs from my acronym SOAP. Same, opposite, and always positive. So this was a plus binomial, so it's still a plus in the binomial. Opposite, minus, and then always positive. And I could box or FOIL those two to see that I get the same x cubed plus 216 back when I get done. So number 3 is the difference of two cubes. So I'm going to do the cubed root of my 125x cubed. I'm going to get 5x. And I'm going to do the cubed root of 64y cubed, and I'm going to get 4y. So my binomial, my first parenthesis, are my cubed roots. So that's my 5x and my 4y. Squeeze those in there. And then I'm going to do the square, the product, and the square. So squaring 5x gives me 25x squared, because 5 squared is 25, and x squared is x squared. Their product, 5 times 4 is 20, and then it's x times y. And then 4y squared, 4 squared is 16, and y squared is y squared. So now I'm going to use my SOAP again, and this was minus. So I'm going to do minus, which is the same, opposite, plus, always positive. Let me change my pen. Sometimes kids make a mistake on this step right here when you've already put your signs in, which is fine. But when I go back to look at this parenthesis to do my product, it's really not a -4 times a +5, which would result in a -20. This is not a -20. So be careful about that. The signs are in your formula. The signs are in the formula with the SOAP. Do not get your signs from your cubed roots, from your numbers that way. You'll have the wrong answer. So number 4, first of all, number 4 has a GCF. Number 4 has a GCF of 3. I would totally take that out. However, if you look at the answer key, I think I didn't notice it before I did this problem. So I'd like to do this as if I didn't notice it, because I think maybe if you don't notice it, how do you take out your GCF later? Like, what do you do to make that happen? So first of all, it's 4 terms, so I know I'm going to do factor by grouping. So let's underline and underline. The 12x cubed and the 3x squared have a 3x squared in common. So after I divide both by 3x squared, I would get 4x for my first term. And then the 3x squared and the 3x squared completely cancel. So it'd be 4x plus 1. And now my next term, I have a minus sign in the middle, so I know I'm going to be factoring out a negative. And looking at the 24x and the 6, they both have a 6 in common. So I'm going to divide both by a negative 6, and negative 24 divided by a negative 6 will give me a 4, and I have my x. And then negative 6 divided by negative 6 will be a plus 1. My parentheses match, so I feel great about it. And so my answer becomes my same parenthesis times my leftovers. This is where you will now see your GCF if you didn't take it out in the beginning. It will be in one of your two parentheses. So please notice my second parenthesis here. That's where I'm seeing my GCF of 3. It's still inside there. And in order to have it completely factored, I need to pull it out. So at this point, I'm going to pull out that 3. We normally stick my integer GCFs just in the front. We still have that 4x plus 1. Nothing's happening to that parenthesis. And now I'm going to divide my 3x squared minus 6 parenthesis by the 3. So I'm going to get an x squared minus 2. That's not the difference of two squares. There's no dots to do here to factor it further. So this is going to be 3 times 4x plus 1 times x squared minus 2. And that would be my fully factored polynomial. So let's see what we have next. Oh, this is going back to the beginning of the unit, pages 2, 3, and 4. This is when we're given the roots, these roots that we've learned how to find, and we have to build the polynomial. We have to create a polynomial that could have these roots. So first of all, on number 5, looking at this one, I know that when x equals 0 is a root, that means x is a factor. If x equals 3 is a root, then x minus 3 is a factor. And I don't really know what factor gives me the complex number 2 plus or minus I. So I'm going to go over here and do some reverse complete the square. So I have x equals 2 plus or minus I. So my first step is I move my constant. So that means I'm going to subtract 2 over, and I get x minus 2 equals plus or minus I. So now my next step is to square both sides. And when I square the right side, I just put my parentheses right through the plus minus because they're going to go away. That's created when I take the square root. So when I square it, it cancels and goes away. On the right side, I have x squared minus 4x plus 4. Don't forget your inner and outer term. And I squared is just negative 1. Be really careful here. I need to get it equal to 0, so I am going to add 1 to both sides and get x squared minus 4x plus 5. And did this say to, I guess I got to multiply this out. Well, that's lots of fun. So x squared minus 4x plus 5. And now I'm going to multiply these. Personally for me, I'd probably multiply my binomial and trinomial first. So I would multiply my x squared minus 4x plus 5 by my x minus 3. And x times x squared is my x cubed. X times negative 4x is negative 4x squared. X times 5 is 5x. And then I have my x squared times negative 3 is negative 3x squared. Negative 3 times a negative 4 is a positive 12x. And negative 3 times a 5 is a negative 15. So right now I've got my x times my answer in my box, which is x cubed. These are both negative, so I'm going to get a minus 7x squared. These are both positive, so I'm going to get a plus 17x. I'm going to finish with a minus 15. So my last step is to distribute my x to all of my terms. I'm going to go ahead and write that on my answer line. So I have an x to the 4th minus 7x cubed plus 17x squared minus 15x. Awesome. So in number 6, again, this polynomial, the x equals negative 1 gives me x plus 1. And I don't know what factor would give me 3 plus or minus 2 rad 3. So I'm going to do some reverse complete the square. X equals 3 plus minus 2 square root of 3. So my first step is to move the constant. The 2 is not a constant. The 2 is after the plus minus. It's the coefficient on my rod 3. So I'm going to subtract 3 from both sides. The 3 is my constant, and that equals plus minus 2 square root of 3. I'm now going to square both sides. So now on the left side I have x squared minus 6x plus 9. And on the right side, I need to square, that's one term, but I need to square each part and multiply them because it's 2 times the square root of 3. So when I square them, it'll still be multiplication or times. So 2 squared is 4, and the square root of 3 squared is 3. So it looks like I'm getting x squared minus 6x plus 9 equals 12. Again, I want to get everything equal to 0. Be careful here that you are subtracting 12 from both sides and getting x squared minus 6x minus 3 for your factor. So let me come back up here. The factor that gives me that answer is x squared minus 6x minus 3. And I will let you have the fun of boxing that all out to get your answer, and then check your answer in our folder to make sure that you did it correct. So let's check out on the next page. The first thing I'd like to point out is before you really get started working, this polynomial is not in standard form. My exponents are not written in descending order. That 2x to the 4th is out of order. So I'm going to write this as p of x equals, and I need to write my 2x to the 4th first, plus my 11x cubed. What comes next? My 9x squared minus 14x minus 8. So now my leading coefficient is a positive 2. My degree is degree 4. I know my end behavior is going to be up because of that when I get to that. How many zeros does it have? Well, it's going to have 4 zeros because it's degree 4. Now it says, given that x plus 2 and x minus 1 are factors. So this wording is kind of newish in the sense that they're trying to tell me that both negative 2 and positive 1 are roots. So this tells me that x equals negative 2 is a root, and this tells me x equals 1 is a root. I think it's hard to see my negative 2, so I'm going to just change that just real quick. So that's telling me that x equals negative 2 is a root, and x equals 1 are roots. So I can break this polynomial down with synthetic division using both the negative 2 and the 1. Since it's degree 4, I do need to do it twice to get to my quadratic factor. It doesn't really matter whether you do the negative 2 first or the 1 first. I will say your work will look a little bit different if you use the 1 first, because in the answer key, I did the 2 first. But technically, it doesn't matter. You can use either one. I'm going to match the answer key. So if you're coming here because you didn't understand it, that will help you. So I'm going to first break it down using my x plus 2 factor, which goes with my root of negative 2. And so my coefficients for the beginning one are 2, 11, 9, negative 14, and negative 8. And I'm going to bring down my 2, and I multiply and I get negative 4, and I add and get 7, and I multiply and get negative 14, and I add and get, what is that, negative 5, and I multiply and get 10, and I get negative 4, and I multiply and I get positive 8, and I get that 0 remainder I wanted to have. So right now, I have my polynomial that's up above is now equal to my x plus 2 times my quotient. My quotient is 1 degree less, so it's cubic. So I've got a 2x cubed plus 7x squared minus 5x minus 4. So now I'm going to break it down again, and this time I'm going to use my x minus 1, which means that in my synthetic division, I'm going to use my root of positive 1. And my coefficients are new this time. My coefficients, I've broken it down to my cubic polynomial. So my coefficients are now 2, 7, -5, and -4. And let's bring down our 2 and then multiply and get 2. I get 9. Let's multiply and get 9. I get 4. Let's multiply. I get 4. And okay, good. I got my remainder of 0. So since this was a cubic polynomial, I've now broken this down to quadratic. So at this time, my polynomial equals my x plus 2 from the beginning, my x minus 1 from the division I just did, times, and I've gone down a degree, to 2x squared plus 9x plus 4. So now that it's quadratic, if I was only looking for my roots, my x-intercepts, I could go straight to the quadratic formula. But if I had to get it in my most factored form, I would need to attempt to factor 2x squared plus 9x plus 4. I'm going to do that. Some of us still having a little trouble when we have to put it into grouping. So let's do this. My a times c is 8 at the top. My b is 9 at the bottom. So I'm looking for things that multiply to 8 while adding to 9. So 8 and 1 come to mind. So now I'm going to rewrite my trinomial. So I'm going to write the 2x squared. And I could write the 8 and 1 in either order, but I am going to put an x behind them because this 8x plus x is replacing my 9x in the trinomial. And don't forget your plus 4. So now I'm going to underline and underline. And my GCF between 2x squared plus 8x is 2x. And I get an x plus 4. And then my x plus 4 has no GCF. So I'm going to factor out a 1 because I always have to factor out something. And I get an x plus 4. I hope these numbers aren't too scrunched up. Sorry about that. And then I get my same parentheses times my leftover parentheses. Now, be careful. Remember, I had a large polynomial. In front of this is still my x minus 1 and my x plus 2. This is still what my original polynomial is equal to. This is my completely factored form. If I had to completely factor this, this is what I would write. So now the next question is, what are the x-intercepts? So to do that, I need to know my roots. So this gives me x equals -2, x equals 1, x equals -4, and be careful here. When you set this equal to 0, you have to subtract 1 over, so it'd be a -1/2 when you divide by 2. So normally x-intercepts are written like coordinates. So I'm going to go ahead and write this in coordinate form. So it's -2, 0, 1, 0, -4, 0, and -1/2, 0. All 4 real roots for my 4th degree polynomial. Well, what's the y-intercept? I get the y-intercept when I substitute x equals 0 into my equation. When I do that, when I plug a 0 in, I get 11x cubed would be a 0. My 9x squared would be another 0. My -14 x squared would be another 0. My plus 2x to the 4th would be another 0, minus 8. It looks like I'm getting, I'm going to write it over here because I ran out of room, 0, -8. Now, I just went back up and used my polynomial in standard form. I probably should have mentioned that. I used the polynomial in standard form. If you use the polynomial in factored form and you substituted a 0 in for all your x's, you'd end up with 2 from the first parenthesis times a -1 from the second parenthesis times a 4 from the third parenthesis times a 1 from the fourth parenthesis. But you would still get -8. You would still be getting 0, -8 for your y-intercept. Describe the end behavior. So it's 4th degree and positive. So I know my end behavior is up, up. So as x goes to infinity and gets really large, my y values, f of x, also go to infinity and getting really large because it goes up. And as x goes to -infinity, my y values are also, well, not also, but my y values are going to infinity and getting really large. So now it asks me to attempt to graph this. So let me slide my paper up. So I need to plot my x-intercepts. My x-intercepts were a -2, a +1, a -1/2, and a -4. There's no bounces, there's no multiplicity. These are all going to be simple zeros. I'm just going to go straight through. I need to plot my y-intercept, which is 1, 2, 3, 4, 5, 6, 7, 8. Looks like it's right about there, -8. My end behavior is up, up. So now I'm ready. I've considered my roots. I considered any multiplicities, which I don't have. I considered my y-intercept, and I'm considering my end behavior. So now I can start graphing this. I'm going to fall down through my 0. Now, my y-intercept does seem to be not quite halfway. If this is 1/2, halfway is really more like right here between my x-intercepts. So I'm actually going to come down to something lower than -8 and then come back up through it, because really it's not halfway in between these two zeros. So now I'm going to go through. I'm going to go somewhere about halfway in between. I'm going to come back down. And then again, I'm going to go somewhere about halfway in between, turn around, and come back up where they actually, oh, I probably shouldn't have made them look exactly the same. Sorry about that. That's not accurate. But this whole thing is not completely accurate. It's just a sketch. So this is simply a sketch. I don't really know where my mins are. All of my turning points in this are a guess. They're an educated guess, being that they are halfway approximately between the x-intercepts. But again, it's just a guess. Yours could be lower or higher than mine. All they are is kind of like just a guess. So, okay, so let's see what's going on the next page. This is a solving page. I'm actually not going to do all of them. So if you're having some trouble and the answer key doesn't help you still, please come to office hours. I will say on number 1, it's not equal to 0. You do need to subtract your 2 over before you get started. But I guess it's number 8. But number 8 and 9 are pretty straightforward factor by grouping problems. So let's jump down to number 10. This is a good example of what's going to end up being quadratic style. There is 3 terms, but I can't just jump to my diamond because it's not quadratic style. Quadratic style is like an x squared plus an x plus a constant, or an x to the 4th plus an x squared plus a constant, which this is not. However, I do have a GCF, and when I take out my GCF of x, I get an x to the 4th plus 2x squared minus 15 equals 0. And now this is quadratic style. So I'm going to do my a times c, which is 1 times -15 up top, and my 2 at the bottom. And I start thinking of my factors of 15, and so 3 and 5. And in order to get a -15, one of them has to be negative. And in order to get a +2, the -1 has to be the 3. So when I factor this, because my a is 1, my -3 and my 5, my side numbers go in my parentheses, but they don't go in my parenthesis with an x. They go in my parenthesis with an x squared. It's quadratic style, not quadratic. So my first term has to be an x to the 4th. I need to be able to multiply an x squared times x squared to get that. And when I do my when I do my inner and my outer, I have to get an x squared term. So that's what's going to help me do it. Now, there's no difference of 2 squares. X squared minus 3. 3 is not a perfect square. So this is completely factored. If this question had asked for me to factor it completely, it's done. However, this question says to solve. So I need to solve this problem. The x on the outside gives me x equals 0. X squared minus 3 equals 0 gives me x squared equals 3. And when I take the square root of both sides, I get x equals plus or minus the square root of 3. So this right here is 3 real roots because plus or minus square root of 3 is just a decimal on my x-axis. So now let's do my x squared plus 5 equal to 0. I need to subtract 5 over. So I get x squared equals negative 5. And I take the square root of both sides, and I get x equals plus or minus I square root of 5. And this then is my 2 non-real roots for 5 total roots for my 5th degree polynomial. So number 11 is the difference of 2 cubes. If you haven't tried it on your own yet, you really should, just to see if you can do the pattern and then come back. So pause this video and try it. But if you have tried it and you're having trouble, let's take a look at it. This is a perfect cube. So is my 1. The cubed root of 8 is 2, and the cubed root of x cubed is x. The cubed root of 1 is 1. So this gives me, in my binomial parenthesis, it gives me 2x and 1. And when I square 2x, I get 4x squared. Make sure you're squaring both parts. And when I multiply 2x times 1, I get 2x. And when I square 1, I get 1. For my signs, I get same, opposite, always positive. Be really careful. If you've already put the signs in, when you do this move right here and you multiply them, don't write a minus 2x. Be careful about that. Sometimes that happens to kids. So this would be what I need to solve now. So I'm going to solve this. When I set my 2x minus 1 equal to 0, I add 1 over, and I get x equals 1/2. That's 1 real root. 1 real root. And the 4x squared plus 2x plus 1, if you did your diamond, it is not factorable. It does not factor anymore. So my choices are complete the square, quadratic formula. This is not a good choice for complete the square. My A is not 1, so I'm not going to do complete the square. I'm going to do quadratic formula. With my A is 4, my B is 2, my C is 1. So I'm going to get my x equals negative 2 plus or minus 2 squared, which is 4. I don't know why I wrote plus or minus. Let me go grab that. Erase that. Minus 4 times. Minus 4 times my A, which is 4, times my C, which is 1. All over 2 times A, which is 4 in this case. So I'm getting x equals negative 2 plus or minus. This is 4 minus 16, and 4 minus 16 is negative 12, all over 8. Let's not cancel anything, because if I can't cancel it from both my things on top, I can't cancel it. So I need to simplify the square root of 12. Let's think about this. This is negative 1. I'm not going to really think about it as 6 times 2. That's not really that helpful. I'm going to think about it as 4 times 3. And when I do that, I get x equals negative 2 plus or minus, and then my negative 1 comes out as an I. My square root of 4 is 2, and then my square root of 3 stays underneath. This is all over 8, but as we've learned in class, when it is a complex number, I have to write it as 2 fractions. Let me move this up a little bit. I'm running out of room. So I would get x equals negative 2 over 8 plus or minus 2I rad 3 over 8, and both of those reduce to my final answer of negative 1/4 plus or minus I rad 3 over 4. And this is my 2 non-real roots for a total of 3 roots for my 3rd degree polynomial. So if I could keep moving this up. Number 12 is a rational root theorem problem. I think that I said to try 4 or negative 4 for this problem. 4 or negative 4. So the one that works is negative 4. Let's try it. Negative 4, my coefficients are 1, negative 2, negative 25, and negative 4. And when I do my division, I'm going to bring down a 1. 1 times negative 4 is negative 4. I get negative 6. I get positive 24. I get negative 1. And finally, I get 4. And it works. So this is now broken down into x plus 4. That's the factor that goes with the root x equals negative 4. And x squared minus 6x minus 1. So at this point, I know that this gives me x equals negative 4. And x squared minus 6x minus 1 is not factorable. So you can use quadratic formula or complete the square. I'd recommend complete the square. So let's do that together here. So I have x squared minus 6x, and I'm going to leave a space and move the 1 to the other side as a positive 1. I'm going to do b divided by 2 and square it. And then I'm going to get negative 3 squared, and I'm going to get 9. So I add 9 to both sides. And it looks like I'm getting an x, square root of the first and the third, an x minus 3 sign from the middle, squared equals 10. We're going to take the square root of both sides. I'm going to get an x minus 3 equals plus or minus the square root of 10. My last step then is to put my 3 on the other side. So x equals 3 plus or minus the square root of 10. Keeping in mind this is 2 real roots here because it's just a decimal. There's no i's involved. And this is 1 real root. So 3 roots for my third degree polynomial. So number 13 isn't set up yet to do because I've got numbers that are on the other side of my equal sign. So let's move them all over. So I get a 2x cubed minus 17x squared minus 32x plus 20 equals 0. And factor by grouping will not work. So I believe the rational root theorem choices we had are 1 or negative 2. And the 1 is not going to work, so I'm going to use the negative 2. And so when I set up my synthetic division with the negative 2, I have 2, negative 17, negative 32, and 20. I'm going to bring down my 2 and start my process. 2 times negative 2 is negative 4. I get, what do I get for that? Negative 21. And then negative 21 times 2 is a positive 42. I'm getting a positive 10, times a negative 2, and I get a negative 20, and that's my 0 remainder. So at this point, I've broken my polynomial down into my p of x is now equal to x plus 2, that's my factor, times then my, I've gone down a degree, it's x squared, so this is 2x squared minus 21x plus 10. And it turns out that this is factorable. So I'm going to factor it. Let's see what I mean. If I attempt to factor it, my a times c is 20. My b is negative 21. And of course, 20 and 1 come to mind. And if they were both negative, they'd multiply to a positive 20. And they would add to a negative 21. So this means that my polynomial is equal to x plus 2 times, I'm going to use brackets because I got a bunch of work to do here. My first term is 2x squared. My last term is plus 10. And I'm going to insert the minus 20x and the minus x in either order. It doesn't matter. So I'm going to underline my first 2 and last 2. And I'm getting x plus 2 times, and my GCF here between these two, it looks like it's 2x with an x minus 10 left over. There's no GCF for my last 2, so I'm going to use a negative 1 so that my x minus 10 in parentheses will match. So my final answer, it looks like it's that x plus 2 in front, the x minus 10, that's the same, and the 2x minus 1, that's my leftovers. So then my roots are x equals negative 2, x equals 10. Don't forget you're going to be adding 1 over, so it's x equals positive 1/2. So let's take a look at your 14. Your 14 is a trinomial. So it could be quadratic style. I don't know what it's going to be yet. But the problem is my exponents. I see the x to the fourth, the x cubed, and the x squared. So I for sure have a GCF of x squared. I look at the 3 and I look at the 9. Maybe 84 is divisible by 3 as well. And if you check it, you'll find that it is. So my GCF is really 3x squared. And my leftover parts is x squared minus 3x minus 28. Now this is factorable. I'm actually going to leave you to finish this yourself, but I want to remind you that once you factor this x equals 0 from the x squared will have a multiplicity of 2. And that's how in the end you'll end up with your 4 roots for your 4th degree polynomial. So let's check out the next page. So it wants me to graph this function. So I need to find the zeros. So I need to start breaking this down in order to do that. So first of all, I know there's 4 terms and you really just want to start factor by grouping. I know. However, there is a GCF. There's a GCF of 2x. But I want to talk about the x part first. It is so important that if you have a GCF of x, you take it out because that's going to be an x equals 0 as a root. It's really, really, really important. The 2 is just nice to take out. It makes it completely factored. It's a factor. I need to take it out. But the x has to come out in order for the problem to work out correctly. Whether you do it at the beginning or later in your problem, you have to take out the x. So let's go through and divide everything by 2x. It looks like I would get an x cubed minus x squared minus a 4x plus a 4. And now I'm ready to do my factor by grouping. I get 2x. This would give me an x squared. I'm going to use brackets so I don't get confused what my parentheses are. And I get x minus 1. Because I have a minus in the middle, I'm going to be taking out a negative 4. But when I divide, I notice my parentheses give me a positive x minus 1. So that's really great. So I get 2x times my matching parentheses was x minus 1. My leftover parentheses is an x squared minus 4. Now at this point, I could set everything equal to 0 and solve, and I would get all the right roots. However, I do want to point out, because some kids are missing it when we just factor, I do have dots here. I could continue factoring, and I would end up with 2x times x minus 1 times x minus 2, x plus 2. And now I'm ready to get my roots. So the 2x is where I'm getting my x equals 0 root, really important. X minus 1 is giving me an x equals 1. X minus 2 is giving my x equals 2. And my x plus 2 is giving me my x equals negative 2, which, by the way, I would have got plus or minus 2 had I solved x squared minus 4 equal to 0 above. So again, you don't have to factor dots if all you're looking for is roots. You have to factor dots if you're trying to factor something completely. So this is actually my answer for A. So if it's okay with you, I'm just going to write A there. And those are my 4 x-intercepts. Let me go mark them. Negative 2, positive 1, 2, and 0. Oh, those are really close together. That's going to be hard with my Apple Pencil. So then what's the y-intercept? Well, if I plug a 0 in for x, I notice everything's zeroing out. So my y-intercept is going to be 0, 0, and I already have that marked on my graph. What's the end behavior? So I notice that this is a degree 4. This is a degree 4 with a positive leading coefficient. So I know that my end behavior is going to be up and up. So now I'm going to create a possible sketch. So I'm going to come down through my first x-intercept. About halfway in between, I'm going to turn it right around and come back up. I'm going to now turn it right back around and come back through. And I'm going to come down a little farther because this has 2 units between them. I'm going to come back up and then put arrows on it. I don't really know where my maxes and mins are. This is simply a guess. It's just an educated guess. It's about halfway in between my zeros. So let's see what some of these questions are asking me. It says, what is the difference between factors and roots. So my factors are in parentheses. It's things like x plus 2 and let's say an x minus 3, for instance. These are my factors. My roots are when I set them equal to 0 and I solve, and I would get x equals negative 2 and x equals 3. These are my roots. These are my factors, and they're both useful. Is every polynomial factorable? No, because sometimes we need to use the rational root theorem because I couldn't factor. And when I use the rational root theorem, I break it down, I break the polynomial down with division instead because I couldn't break it down with factoring. How does multiplicity of a root affect the graph? Well, when you have an even multiplicity, there is a bounce on my graph. And when I have an odd multiplicity, there is a bend on my graph. Will every odd degree function have a real 0? How do you know? Why don't you think about this for a minute and then come back and we'll talk about the answer. Think about this one. So actually, yes, every odd degree function has to have a real 0. And you know why? It's because it has to have, for example, let's take a third degree. A third degree would have to have 3 roots. And so that could either be, your possibilities are 3 real roots, or if you have a non-real root, remember, non-real roots always come in pair. So you would have 2 non-real roots because when you have non-real roots, there's always a plus minus. So there's always 2 of them. And so then you would have to have 1 real root to get your 3 total. Same thing happens if you have 5 roots or 7 roots or 9 roots. You're always going to have 1 real root because your non-real roots have to come in pairs. Will every polynomial function intersect the y-axis? Well, this is just saying, could you have a polynomial that doesn't intersect the y-axis somewhere? And the answer to that is that no. The answer is yes. Will every polynomial intersect the y-axis? The answer is yes, because there's no way for your polynomial to go from, have a domain from negative infinity to infinity and not cross the y-axis somewhere. So the answer to that is yes. Every polynomial has to intersect the y-axis. I think before I was asking, is it possible for it to not? And no, it's not possible because all of them have to cross it at some point in order for my graph to continue, my curve to continue from negative infinity to infinity. So thank you so much for listening, and I will see you in class.